Hey, welcome to the last video for the week on long-term memory, the last component of the Atkinson and Shiffrin model. So basically, information can move into long-term memory when it's been worked on enough in short-term memory. So it has to be encoded or elaborated on or linked to other existing memories. And this is the only way that information can move on. If you then retrieve something from long-term memory, it goes back into short-term memory where we can continue to work on it, alter the memory in some way, and then we can make it go back to long-term memory to be stored. This kind of is what happens when we talk about misleading questions and false information, and you've got a memory, it's in one format, you bring it back to short-term memory, you talk about it, some people might suggest a new aspect of the memory, then you store that new memory. So you've worked on it, but it means that it might not be that exact anymore. So information in long-term memory is stored mainly according to the meaning. So information is like a little filing cabinet or category system in your mind or in your long-term memory. So we'll learn a little bit more about that next week. We say that long-term memory has relatively unlimited capacity and duration. We can't say it's 100% permanent because we know that things like brain damage, strokes, those kind of things can actually affect our memory and cause amnesias. So providing you're healthy and well, if you store a memory, it should be there forever, and there's no limit to how many we can store, providing you're doing the process right. We know that sometimes we can't find these memories because we've talked about the 4 theories of forgetting, but they're there and they haven't gone away. Elaboration is a technique that you can use to get information from short-term memory to long-term memory. It's called elaborative rehearsal. In the previous video, we talked about maintenance rehearsal, which was just repeating the information over and over again. Elaborative rehearsal means that you're actually adding to the information in some way. So the mnemonic devices that you learnt about in the last couple of weeks, narrative chaining, acronyms, acrostics, they're all examples of elaborative rehearsal. And you just need to remember that the word elaboration means adding, so making the memory more creative in some way, or even just meaningful. So even if it's thinking of your own example of when something happened, if you're learning new content, that will help you store that memory. Atkinson and Shiffrin came up with this multi-model of memory mainly through 2 pieces of information, and that was through brain damaged patients, which we'll talk about a little bit later when we get to amnesia, but also through the serial position effect, which you've had a go at in class. So that's when you're given a list of words to remember, and after you're given the list of words, you're asked to recall as many items as possible, and what we find is that items at the start and the end of the list tend to be remembered better than those in the middle. So you can see there a bit of a look at what a typical serial position effect would look like. The components of the serial position effect really support Atkinson and Shiffrin's model of memory. So the first part of the list, which is called the primacy effect, so that's superior recall for items at the beginning of the list. The way I remember that, primary comes before secondary school, so at the start. Generally, these items are rehearsed and transferred to long-term memory. We often have a little bit more time, so we repeat them, add to them, think about them. Some people even create a story about them. So these words tend to be elaborated on, and we have time to move them to long-term memory. Recency effect explains the superior recall of the items at the end of the list, and that's because these items are still within short-term memory, because we know we can hold information there for somewhere between 20 and 30 seconds. So if you recall the list straight away, those words should be there straight away, and often you see people will write those words down first, then they'll go to the start of the list and write the items down that were in their long-term memory. You don't see the recency effect if there is some sort of time delay or distraction task. So if you were to remember a list and then be asked to count for more than 30 seconds, what that does is the numbers take over what's in short-term memory, and the last few items on the list will fall out. So you only see the recency effect if you are given a chance to recall the list immediately, which is what we did in class. The items in the middle of the list are not elaborated on at all, so they don't go into long-term memory. And they were in short-term memory, but the words at the end of the list have displaced them because we know that short-term memory has a limited capacity. So basically the fact that this effect, the serial position effect, happens time and time again when people are asked to remember a list of words really supports the idea that Atkinson and Shiffrin had about sensory memory, short-term memory and long-term memory being quite separate stores of memory. I guess the only problem about this particular model is that when we direct our attention, history says that what we know to be important or what we decide to pay attention to is determined by our long-term memory. So our long-term memory kind of needs to speak to our sensory memory. But if you think about this particular model, it's sensory memory, short-term memory, then long-term memory. And it almost implies that long-term memory has got no direct connection to the first substore, sensory memory. But yeah, I'm sure you can think of an example. So for instance, if you've walked through a door before and let's say a bucket of water has fallen from the top of that door, you would remember that enough that when you go to walk through doors at a later time, your attention would often be drawn to the top of the door to see if someone's playing a practical joke on you. The model doesn't explain how that happens, but we know it happens. We know that long-term memory definitely helps direct our attention in our sensory memory. So just something to think about, and obviously we'll learn a couple of other models of memory and we'll see whether either of those sit better with you. I'll see you in the next video.